Hello everyone, welcome to the webinar about the Advanced Reactor Technologies, Small Modular Reactors and Microreactors. Today we have two speakers with us, Christopher from TPU and Linux from MIFI. So without any further ado, let's go to the subject. So I will welcome Christopher to talk about background to the development of SMR technology. Christopher, the floor is yours.
Thank you very much, Anchuan. Hello, everyone. So like my colleague said, today we'll be talking about advanced reactors, and particularly we would give a little more background to small modular reactors. My name is Christopher Abrifa Watson, and I'm a postgraduate student in Thomas Polytechnic University. So without much ado, I'll move on straight to this first slide. What we are going to do today is to talk about a little background to the small modular reactor technology. So by way of outline, I'll give an introduction, share with us some major factors that are influencing the development or the deployment of small modular reactors. I'll tell us the small modular reactors that are now in operation, and I'll just give us a little history about some old reactor technologies that were considered as small because of the capacity of the size of the power that was generated. So let's move to the introduction. So much more like any other technology, nuclear power has also been advancing from time to time. And so when you look at the reactors of the 1960s or the 1970s, they are quite different from the reactors that have been built in the 2000s or the 2005, 2010. This is to mean that there's constant improvement, constantly engineers are working on how to make the reactor technology more useful. And basically, this has led to global efforts where new designs and various propositions have come up in order to make sure that the nuclear technology is much more useful, much more beneficial. Basically, we are trying to improve on how we can make nuclear power accessible to every other country that is trying to go nuclear. So one of the directions that has gained a lot of attention in recent years is the small modular reactors. And in this webinar, myself and my colleague would give us a little information about it. Can we move to the next slide, please? So the small modular reactor technology has been in discussion for some years now, and it has a pretty interesting characteristics, which has made a lot of stakeholders. When I talk about stakeholders, I'm talking about the government authorities, the nuclear agencies that are thinking of how to advance nuclear technology. These are the people I'm referring to as stakeholders are considering. In the first place, one big challenge to deploying nuclear power plants has to do with the construction time. It takes a long period of time, and this has a direct correlation with the cost. And also, a lot of times, most nuclear power projects are not able to go according to the construction timelines. So engineers have thought about it, researchers have considered to deploy a technology where we will make the size of the whole reactor plant smaller. So small modular reactors in comparison with the traditional reactors are smaller. And they are smaller because they are modular in the sense that we are able to manufacture them in the factories, assemble them. And these advantages have made it pretty attractive to people who are developing modular reactors. Also, within the years, all the knowledge that has been gained through the operation of nuclear reactors has been factored in advancing these nuclear reactors. So SMRs have an advanced and safe designs. Because we are considering reactors that have pretty small thermal capacity, that is between 10 megawatts and 300 megawatts, it is proposed that small modular reactors will give some economic benefits. Also, we have flexibility and scalability, which talks about the ability to deploy small modular reactors in such a way that if you have a need for more power in future, you can add several modules. And one also interesting proposition for SMR deployment is to replace the aging fossil fuel units that exist now. So these are some major factors that are influencing the development of small modular reactors. And to be frank, there are a lot of designs that have been put forward because these advantages seem very credible by a lot of standards. So let me tell us the global status of SMRs now. Can we move to the next slide, please? So when you check the IAEA's website, there are propositions of about 80 SMR designs, which are under development and in deployment at different stages. So all of these 80 designs are fission reactors, which are using different kind of technologies, but they all fall within the small modular reactor technology. My colleague will give us a little information about some of them, but here what I want to focus on is that there are a whole lot of reactors that are being developed at different stages, which are considered as small modular reactors. Next, please. So the concept of small modular reactors, although it has gained recent attraction in the few years after maybe 2000, there has been propositions for small reactors back in the 1950s. This was basically due to military programs that were considering how to get energy for their military purposes. So there were researches that were conducted both in the United States, both in the Soviet Union, that were considering developing power sources that could last for a long period of time. So when we look here on the slide, we talk about the research that were conducted in 1950s. And the basic driving forces for some of these developments or researches was to provide electricity in remote areas. It was also to reduce the burden of petroleum fuels and other logistical support for diesel generators, to provide mobile reactors that can be quickly transported and deployed. So because of these needs of the Army, there were some researches that led to actually the development of small modular reactors, or let me call them small reactors because of the size. So for instance, in the USA, we had the SMR reactor, which is stationary medium reactor. We had the ML1A reactor and the LL1 reactor. So in the Soviet Union too, there were a lot of naval programs that led to developing reactors for the naval ships and other installations. So all of these reactors that were developed had low thermal power and they were considered to be small. During these researches, a lot of relevant information was obtained that was able to prove that we are able to construct reactors at small scale. And in the next slide, I'll show you some pictures of very, very old small reactors. Can we please move to the next slide? So when you look there, we can see a transportable nuclear reactor that was called TS3. It was built and operated from 1981 in the USSR. So these reactors were small in size and they were not producing very high amounts of thermal power like the conventional ones we have. I mentioned SM1. We can also see the ML1, and then you can also see the Sturgis. The Sturgis was also a nuclear reactor that was used by the Navy in the early 20th century. So after these researches, can we move to the next slide? A considerable amount of information was gathered, although for some reasons the research was discontinued. the people involved, the companies that were involved, gathered a lot of information that was very valuable and continues to be valuable and helps in the development of small modular reactors in recent times. Also, the problems that is associated with traditional and conventional nuclear power plants, which, as I said earlier on, requires more time for construction and also has a problem of high cost persist. That is how come we have seen that over the years, the number of power plants that have been built remains very, very low. So we also note that in the years that we are in, a lot of the reactors that have been operating for a long time are getting to the close of their life cycle. And also, it has been established that the SMR technology is a key for clean and reliable and also efficient energy generation. So in order to combat climate crisis, the SMR technology has also come back to fore, and a lot of research is being conducted by people, by institutions, by companies, such that we can develop new reactors to replace these aging reactors. Henceforth, the small modular reactors have gained a lot of attraction in these times. Let's go to the next slide. So over here, I would mention some significant events that is showing the resurgence of small nuclear reactors. So first, I'll talk about the Generation 4 International Forum. So this international forum is a number of countries that are facilitating the deployment of the next generation of reactors. And these are innovative designs that hope to increase the efficiency of nuclear power plants and also decrease some of the safety concerns that have been raised over the years. So in 2000, it was proposed that by 2030, some of these reactor designs will be deployed. And I want to also mention the fact that there has been a global trend in SMR designs, like we saw in the previous slide. About 80 different institutions are working to produce 80 different kind of SMR designs. This shows that a lot of attraction has been gained by the technology. And recently, there have been in the IEA a creation of regulators forum. And this is an initiative that is seeking to boost the deployment of small modular reactors. Since these reactors have not been in operation for now, one big challenge is that there would have to be a comprehensive review of how best to regulate these modular reactors. So in this sense, a regulators forum has been created, and there's cooperation from all over the world and member countries in order to be able to find out how best to modulate some of these challenges when it comes to the deployment of small modular reactors. I mentioned earlier on the climate change conference that was held in 2019. Basically, the focus was that let's try to boost small modular reactors such that we can be able to achieve our goals, our climate goals. That is to reduce our dependency on fossil fuel and make sure that our world is safe from greenhouse gases. Also, one interesting fact is that there has been a lot of funding that has been given to some of these small modular reactor startups. For instance, in the UK, in the US, in Canada, in Russia, and in China, there have been significant investments to the small modular reactor technologies. So noting this, you can realize that there is a direction towards small modular reactors because of the possible benefits that they provide to the nuclear industry. Can we move to the next slide? So over here, I'll mention two major small modular reactors that are operating now. My colleague may talk about the details of it. But in 2020, the Russian Federation started operating the academic Lomonosov. And this is a floating nuclear power plant, which is now recognized as the first small modular reactor. So this is to show that small modular reactor is not just in the research phases, but is also now practically existing and serving the needs of the community of people in Pevek, which is in Russia. Secondly, to the next slide, China also started operating a high temperature gas cooled pebble bed reactor. This also is classified as a small modular reactor and is the first of its kind. It's a very incredible research that has been ongoing, and presently it is the first fourth generation small modular reactor that is existing. So all of this is to show that the research towards implementing small modular reactors is actually gaining a lot of results. That is to show this in particular. So let's move to the next slide, where I'll show us a map of how SMRs are being developed. So when you look over here, you can see that about these 80 designs that are mentioned, it's actually spread throughout almost all the continents. And I'll not mention the details here. I'll leave that for my colleague. But I want to say thank you all so much for listening to my presentation. And thank you once again.
Thank you very much, Christopher, for your valuable information. Let's welcome our second speaker, Lennox, to speak about more about the SMRs. Lennox, your floor is yours.
Thank you very much. Good day to you, everyone. My name is Lennox, and I'm going to take you through the strategic role of small modular reactors. So the question is, why do we need small modular reactors, and what are their significance? So the strategic role of small modular reactors in the current scenario, whereby you have increasing global energy needs, and we have the problem of climate change. We need a sustainable energy source, and that is nuclear power. But there are cases whereby we cannot have nuclear power factories, or we can say nuclear power plants, full scale. So that's where small modular reactors come in. So today we are going to talk about uh, what are small modular reactors. My colleague have given you in-depth detail about what are small modular reactors, but I'll touch on top. Then we are going also to discuss their key design features and scientific phenomena behind them. Then we'll talk about the challenges and opportunities and also future developments associated with small modular reactors. So uh, let's small modular reactors are defined as nuclear reactors with the power outputs typically between 10 to 300 mega electric watts. So they are characterized by their size, the capacity, and also the modularity, whereby we are saying they can be constructed in a factory, then transported to the site where they are to be um, used. So we are saying this modularity of small modular reactors, whereby we are saying we can add modules to realize an output which is desired, the desired output, makes them so much helpful for remote areas and places whereby, or countries, let's say, whereby they have a grid which does not support 1 gigawatt of power. So the small modular reactors are not distinct type of reactors, but rather a family of different reactor designs. For example, we have the academic Lomonosov, which is the world's first floating nuclear power plant, which is an SMR. It has got two small modular reactor units, each 35 megawatts, and they've got a total capacity of up to 63 megawatts, supplying a town which is at the off-grid or near, we can say, outskirts of Russia. And in 2022, we had an first offshore power plant which is small modular reactors, which was developed by a company in the United States of America. It was called the Voyager small modular reactor. The company which developed it is called the New Scale Power Development. So these are the examples of small modular reactors we have in our amongst us. So now let's talk about how small modular reactors works. So as we have already said, small modular reactors are not a distinct type of reactors, but they are a family of existing reactors. The main phenomena which is being used in small modular reactors is the same as the other reactors, which is nuclear fission. Well, we are hoping that when nuclear fusion comes, maybe it will be applied in small modular reactors first, because it will be such an revolutionary work. So we are saying as the atom is splitted, it produces energy. That energy mainly is heat energy, which is, this happens at the core of the small modular reactors. So its size as compared to an atom, as the compared to the anatomy of a human is shown in the diagram in the presentation. So at the core, that's where the fission happens. So we have control rods which control uh, the heat produced and which turns on off the reactions. Because what happens is there's a chain reaction which goes on and on, splitting of nuclear atoms. So when these atoms are split, they produce the energy. This energy is used to heat water to produce steam, and this steam is used to turn turbines. These turbines turn and produce electricity. So for safety features, we have reactor coolant pumps, and these reactor coolant pumps make sure that our small modular reactor does not overheat, and we have the pressurizer, which uh, makes sure that the water does not boil. So moving on, this is just an overview of how simple SMRs work. So we have been asking the question, are small modular reactors a new thing or new technology? But they have been thought to be existing, as described by my colleague, that they've been used in propulsion in the 1960s for propulsion of ships uh, in the wars and stuff. So right now we have a diagram depicting the deployment timelines of small modular reactors, which we have. And as you can see from the diagram, there are various small modular reactors which are in different stages. We have, because in the licensing and deployment of small modular reactors with different stages, such as the uh, commissioning, design, certification, design approval, and so much more, licensing and stuff. So we have approximately about 95, 93 small modular reactors which are in different stages around the world. So there's a hope that small modular reactors will be a sustainable source of electricity in the coming century. So right now, as we've discussed earlier with the academic Lomonosov, which was deployed in 2019 uh, in the Russian state, and with the Voyager, which was deployed in the 2022 in the United States of America. So these diagrams depict how SMRs are moving in their timelines from ideation to deployment. Now let's look at the key design features and the scientific phenomenon behind small modular reactors. So as we have seen, they use the same phenomenon of nuclear fission. But what makes them special is their modularity. The fact that they can be constructed in a factory and be transported to site reduce uh, the timelines of constructions and also cut certain costs. So that gives them the potential to reshape energy systems and their alignment with the environmental and economic goals, because we wouldn't have the need to increase land pollution and air pollution and stuff in the preparation of the site where they'll be moved and located. So they also have a very distinct special attribute which they have, which is the safety part of it, them, because the passive safety system, this passive safety system does not rely on human intervention. So it means that uh, small modular reactors can shut down automatically in terms of an accident or mis uh, miss, we can say maybe working a problem. So we are saying the small modular reactors have this passive system that rely on natural physical phenomena such as gravity and convection. And also another advantage of them is the fuel cycle. So small modular reactors operate on a different fuel cycle, which includes longer intervals between refueling. So we are saying the our nuclear fuel is, like we can say, efficiently used, because we are saying it stays longer in the reactor and we have lower waste. So in the case of radioactive waste, it's a win situation. So the other thing we can talk about on small modular reactor are their heat generation and thermal efficiency. They've been discovered to have very high thermal cycle, very high efficient thermal cycles, which have been making them talk of the show. So we are saying small modular reactors, they're very good uh, for very wide energy solutions. So in that case, we are saying now we can look at their challenges and opportunities they have and the future advancements. So as you can look in the depicted diagram, we have different small modular reactor designs around the world. As we have, as it has been articulated by my colleague Chris, uh, we have land-based water coolant reactors. We have the marine-based water coolant reactors, the molten salt reactors, the high temperature gas cooled reactors, and also the fuel and micro reactors. So these small modular reactors, uh, different designs around the world, gives it, we can say, a secular perspective that we have not only one design which is being used, but it shows that technology is being developed in different aspects. And if we have a combined solution, small modular reactors are a reality. So now let's go next, whereby we will be looking at the challenges and opportunities around small modular reactors. So starting with the opportunities, there are economic drivers. Why are we saying so? Because they have the potential for lower capital costs and the ability to match energy demand growth. So you're saying as energy demand changes, maybe we have had a small modular reactor which is producing 300 mega electric watts, and we've discovered in a year our demand is increased maybe to 400 mega electric watts. So with small modular reactors, we can add other modules to match that demand. And there's also a high market opportunity because we are saying they have the ability to provide energy solutions for remote and off-grid applications. And looking at the continent of Africa, most countries do not support a 1 gigawatt grid. So small modular reactors come as a sustainable solution to them in the fight of climate change and energy crisis. So also, the advanced materials which are being used in small modular reactors make it as an opportunity for countries with such raw materials, right? And now looking at the challenges they are facing is the regulatory aspects, which is the major challenge, because licensing and regulation are critical for the deployment of small modular reactors. So we are saying these processes take a long time, which might make it a challenge to countries to have a fast energy solution, because we are saying small modular reactors may take up to around 5, 10 years before they are being deployed, from the process they are ideated to the process whereby they are trying to be deployed. So the technology and future endeavors are to shorten that time and make sure that more modular reactors are available for different countries. Then, there's also the issue of advanced materials. Yes, the other countries which have these materials may gain in the game, but we are saying it's so difficult to have these materials which withstand very high temperatures and radiation levels within small modular reactors. So innovations will be needed in order to overcome this challenge. And in conclusion, we are saying small modular reactors, they offer what we call an opportunity for countries with nuclear raw material reserves, but at the same time, they are not capacitated to facilitate a conventional nuclear power plant. So for small modular reactors, cultivate these raw materials, and they've given these countries an unlocking potential. Not only that, but they are a strategic instrument in giving sustainability aspects of energy, so that they may be used together with renewable energies and in other applications like hydrogen production to fight climate change. So thank you for listening. And if you have any questions, you may write to us in the given contact details. And we're delighted to have you. Thank you.
Thank you very much, Lennox, for your time and your content. So, dear audience, that's all for today's webinar. And thank you for attending. And stay tuned with our social media sites for further events. Thank you very much.